All right, guys, so quick review on the Pythagorean Theorem. You're going to be needing this for the rest of the chapters. It's something that a lot of you have seen before, but I just wanted to review it with you really quick. So when you have a right triangle, now this only works when you have a right triangle. We label it like you see right here on the right. The hypotenuse, which is the side across from the 90 degrees, we call that the hypotenuse. That we always label it as C, okay? The other two, the A and the B, it doesn't really matter which one is A and which one is B. Theoretically, it's the same idea. So when you have a right triangle, there is this rule, this theorem called the Pythagorean Theorem that is always true. So if I take the side A and square it, and then I take the side B and square it, add those together, I get the hypotenuse squared. So I get this formula, a squared plus b squared equals c squared. What this means is if I know two of the sides of the triangle, if I know A and B, I can figure out what C is. If I know B and C, I can figure out what A is. So we only need to know two sides of a right triangle to find the third side. So let's do a couple of these, let you see some examples to remind you how it works. So the first one says that a right triangle has legs of length 10 and 24. So what that means when it says legs, it does not mean the hypotenuse. It means these two are 10 and 24. What is the length of the hypotenuse? Well, my formula tells me that 10 squared plus 24 squared is equal to c squared. So if I do 10 squared, I get 100. If I do 24 squared, I don't know what that is. 24 squared is what, 576? So 100 plus 576 is equal to c squared, which means that 676 is equal to c squared. Now to figure out what c is, to get rid of that squared, all I have to do is take the square root of both sides. So square root of 676. Now sometimes this is a nice number, sometimes it's not. 676, enter. This one gives me 26. So that tells me that 26 is equal to C. So this side is going to be 26, all right? Similar idea. It gives me a right triangle. It gives me sides of 8 and side of 15, and it wants me to find x. Well, x is my C value, it's my hypotenuse. So 8 squared plus 15 squared equals C squared. So 64 plus 225, I think. 15 squared. Nope, 15 squared, guys. Come on. Yep, 225. 64 plus 225 equals C squared. So 289 is equal to C squared. When I square root both sides, I get my C value. So I do square root 289, and I get 17. So C is equal to 17. Now, you'll have to read the answers carefully or where it wants you to put in the answer, because sometimes the numbers are not going to be, they're not always going to be nice numbers. You might end up with a decimal. When you take the square root of a number, it might not be something that you can square root. So which means you just get an ugly decimal, which is fine. It'll tell you how to round if you need to. So number 3, this time it gives me C and it gives me one of the legs and it wants me to find the other. It doesn't matter which one you call which. I can call this one A and this one B, which means x squared plus 4 squared is equal to 7 squared. So x squared plus 16 is equal to 49, which means x squared, when I do my railroad tracks, x squared is equal to 33 because I minus 16 from both sides. So when I take the square root of both sides, x is equal to the square root of 33. So on this one, it says to express your answer in simplest radical form. Radical form means leave it as a square root. That's what radical form means. It doesn't want an ugly decimal. It wants you to just say x is root, whatever the square root of 33 is. Okay. Number 4, again, it gives me the hypotenuse. It gives me C, and it's looking for the two legs of the triangle. Well, in this case, they're both x's. So x squared plus another x squared equals 6 squared. So that means that 2x squared equals 36, which means that x squared is equal to 18. And when I square root, x is equal to root 18. Which is if that answer, there's nothing wrong with that answer at all. In fact, I like that better than the decimal version because it's an exact number. It's not a rounded decimal. So be careful when you're putting these in for homework 25. Make sure that you read how it wants you to round or if it wants it in radical form if you don't get those nice, pretty numbers.